And if at any point you need to pause the video, or if you run out of time in class, you don't get to finish the video, you can go home and finish watching it. You can re-watch parts that you might have missed, and you can catch up on these notes. Okay, so number 3, we have 3 to the x power equals 1 over 27. Okay, we need them to have the same base first. So we have 3 to the x power. How are we going to get a base of 3 with 1 over 27? Okay. Now, we know that 3 cubed is 27. So how are we going to get 1 over 27? And the only way to do that is if we flip it. And to flip it, we need a negative exponent. Okay, so my x would equal negative 3 on this problem. All right, number 4, we have 9 to the x plus 1 equals the square root of 27. Okay, we need the same base. Now, there's no way to have a base of 9 that'll give me 27, because 9 to the first is 1. 9 to the first is 9. 9 squared is 81. There's no way to get 27. So we're actually going to have to manipulate both of these to get the same base. So the only base that'll work for both would be 3. 9 would be 3 squared to the x plus 1. 27 is 3 cubed. And for now, I'm going to leave it under the square root. I'm going to take it one step at a time so you know kind of what I'm doing. All right, so we have the same base. Now we need to condense it, simplify it. So power to a power, I'm going to multiply those together. Now, a lot of people want to just put 2x plus 1, but that's not it. You have to distribute that 2 to each term in that binomial. It's actually 2x plus 2. So take your time, work on those algebra skills, and do it right. Now, if I have the square root of something, remember how we said that's like saying to the 1/2 power? Okay, rational exponents are back. Okay, we're going to use those too. So, square root is like 1/2. If you remember, if we took the cube root of x squared, it's the same thing as x to the 2/3. Okay. Like I said, rational exponents, you're going to have to remember how to do those too. Alright, so back to our problem. We have 3 cubed to the 1/2. So power to a power, we're going to multiply them. So that would be 3 to the 3/2. And now it's condensed. Okay. Now I can set my exponents equal to each other and solve for x. So I'm going to save my x for last. I'm going to subtract 2 to both sides. So 2x equals 3/2 minus 2 is negative 1/2. Okay, divide by 2 to both sides, and you get negative 1/4. Alright, so I want you guys to try the last 3, and then we'll check. So I'll give you about a minute, because you don't have very long. These notes took quite a bit of time. So I'm going to give you a minute. Go ahead and try them out, and then we'll check it. Number 5, we need the same base. So we can put them both in a base of 5, where the first one would be 5 to the negative 1, and all of that to the 2 minus x. And on the right side, that would be 5 squared. So if I distribute that negative 1 to my exponent, I get 5 to the negative 2 plus x equals 5 squared. Okay, then I can solve for x. So save my x for last. I'm going to add 2 to both sides, and x equals 4. Number 6, I need the same base, so I can put that 4 in a base of 2 if I put 2 squared. So this would be 2 to the 2x power minus 2 to the x equals 0. Okay, now there's no way to get 0 from a base of 2 or a base of anything. If you remember, exponential functions had that horizontal asymptote where they never touch 0. So there's no way to get that as a base of 2. So what you can do is move one of these other terms, like I can add 2 to the x power, and I can move it to the other side, and now I have a base of 2 on both sides, and then I can set my exponents equal to each other. So 2x equals x. If I'm going to solve for x, I need my x's to be on the same side. So you can move them to the left or to the right, it's totally up to you. Let's say we move it to the left. Okay, I'm going to subtract x. So that would be 2x minus x would be 1x, or just x equals 0. Like I said, I know I'm going kind of fast, but you can rewatch them later, rewatch the videos, finish up the notes later when you have more time. Last one, okay, they're both in the same base, which is good. But here we have a power to power. We're going to multiply those two. So x times 2 is 2x. Everybody wants to put x squared, and that's not it. X times 2 is 2x. Okay, so we have 2x equals x squared. Get your x's on the same side. So I like to keep my x squared positive. To me, it makes it a lot easier. So I'm going to move that 2x to the right. So 0 equals x squared minus 2x. Okay, so we have a quadratic again, which means you're going to factor. So complete the square quadratic formula, whatever method you choose, but you are going to be factoring. So whenever I factor, I'm going to look for the greatest common factor, and they both have an x. So I'm going to pull an x out of both. So I'm left with x minus 2. Okay, you should remember that from factoring a few months back. Okay, so now we can split these apart. Remember how I said if you don't remember the trick, you can set them equal to 0? Okay, I'm going to set each one equal to 0. So on the first one, if I set it equal to 0, x is 0. Second one, if I set it equal to 0, I have to add 2, and x equals positive 2. Okay. You have a worksheet. Like I said, re-watch these videos if you need to. On the worksheet, you're going to omit the last section. So omit problems 15 through 18. Okay. The work for the next couple of days isn't as hard, or isn't as much. So the notes are a little less. The worksheets don't take as long. So if y'all have questions on anything, y'all can ask me. If you don't have time today, you can ask me tomorrow, and I can help you guys out. All right.